Hey boys and girls, this is lesson 6.4, Partial Quotients Division, Part 1. Make sure you get that written in your notebook as well as today's date. When you have that done, come on back. Okay, so here's the math message for you. So the art club is making a rectangular mural for the gym wall. They have 98 square foot tiles. So 98 square foot tiles. If the club members want the mural to be 7 feet long, how tall will it be? So when you think about that question, we want to ask ourselves a few things to help set our brain up. So what do we know? Well, we know the mural is a rectangle. We know that its length is 7 feet and that it's 98 square feet for an area. Okay, so we know that. What do we want to find out? Well, we want to find out this height over here, right? How tall is it going to be? So if we wrote it as a number model with a letter standing for the unknown quantity, you would see we would have this. 98 divided by 7 equals h for height. You wouldn't have to use this exact one, but that's a good one. And if we estimated the height of the mural, we could think about this like this 98 we could round to 100, the 7 to a 10, so 100 divided by 10 is 10. So we can imagine it's going to be about 10 feet high. Alright, take some notes on that. When you feel good about what you have written in your notebook for this problem, go on to the next slide. So, with all those things in mind, how do we actually solve it? Well, there's lots of methods. Let's talk about a few of them, and then I might be teaching you something new today. So, we probably could use repeated subtraction. I could take out 98 cubes or pennies or something, and I could keep taking away groups of 7 until there's no cubes remaining. And the amount of piles of 7 that I would have pulled away from that gives me 14, and that's the quotient, the answer in a division problem, the quotient. Okay, so that's one way I could have done it, is this way. Or I could draw a picture. I could draw an array to represent the rows of 7 tiles, and if I kept doing the 3, 4, 5, 6, 7, if I kept doing that until I got to 98, I would see that I'd end up with 14 rows of those, right? 14 rows all the way high would get me to 98, so I could do it that way. I could use the multiples method. I know 10 sevens equals 70, 11 sevens, 77, and so forth, until I could see that 14 sevens is 98. So those are 3 very solid methods. But I want to teach you one that's even easier once you get the hang of it. I won't say it's easy right off the bat, but you'll eventually, I think, find it to be so. So let's take a look. Oh, take yourself some notes there if you need them on this page as well. Okay, so a newer way would be to partition this rectangle. This may sound familiar to you. We did something along these lines earlier this year with multiplication. Now we're going to use it for division. We're going to partition the rectangle to decompose 98 into smaller, more manageable for our brain chunks. So first we're going to draw and label a rectangle to represent the number story. I did that on the first screen because that's what naturally my brain does for me when I'm solving a problem like this. But let's go ahead and make sure you have this really clearly in your notes. So get this drawing made for yourself. And then let's take a look at a few things. So our drawing shows that we don't know the mural's exact height, right? We don't know. But do we know it's at least going to be 10 rows of 7 tiles? Well, we should, because we're trying to get to 98, and we know that 10 times 7 is 70, and 70 is less than 98. So I could know it's going to be at least 10. Could I know it would be about 20 rows of 7 tiles? Hopefully you'd say no, because we know 20 times 7 is 140, because 2 times 7 is 14, and I've got 1 0 to add to my answer, right? Okay, so 20 times 7 is 140, and 140 is greater than 98, so it definitely can't be as big as 20, but it's at least 10. I'm going to show that on the next slide. So here's how I might show that. So we've got 7 times 10 is 70. I'm going to break this off, and I'm going to mark it just like you see here. Okay? I'm going to be doing this math work over here on the side. So I had 98 total. I'm going to take away 70. That's going to leave me with 28 if I do a subtraction problem. Okay? So how many rows of 7 tiles can we make out of the 28 tiles that are left? Hopefully your brain says to you, wait, when I see 7 and 28 together, I know the missing number in that fact triangle is going to be 4. Okay? We know we can do 4 more rows of 7 tiles because 4 times 7 is 28. So I'm doing that work over here to get myself to 0. I'm doing that work over here. 4 more rows. 7 times 4 is 28. So I'm going to add the 10 and the 4 to get 14. I could have written the 10 over beside this and the 4 over beside this and gotten to 14 as well. Alright, so we know the height of the mural would be 14 feet because 10 plus 4 is 14 rows of 7 square foot tiles for a total of 98. Okay? 98. 70 and 28. 98. So that's the way I could solve that. Take some good notes on this page. Go back and listen again if it's a little bit confusing, but I think you'll get the hang of it. We're going to go on and do a different problem on the next screen, so make sure this one is clear for you. Okay, so partial quotients division. It's a really efficient method for solving division problems. It is all about breaking it into smaller chunks for myself. It's a simpler way of writing it out. Rather than having to do a whole rectangle, I'm still using smaller chunks. So that's what partial quotients is all about. Quotient is the answer in a division problem, and I'm going to do partials of those. Should sound familiar. Partial products. Multiplication is what we use for that, right? And now we're talking partial quotients, division. Okay, so let's use it to do this problem. So Mrs. Kelly needs 72 muffins for a party. The muffins are sold in boxes of 4. How many boxes does Mrs. Kelly need? So let's do the same method we did on the last one. Let's ask ourselves some questions. What do we know? We know 72 muffins in all, and we know 4 muffins per box. What do we need to find out? The number of boxes. So if we wrote a number model with the unknown, it would be this. 72 divided by 4 is how many boxes? B for boxes. And if I estimated how many boxes I would need, just to give myself a ballpark, set my brain up for success, I could say 80 divided by 4 is 20. So about 20 boxes. That's what I should be thinking about. Okay? Jot some notes and then come on to the next slide. Okay. So I'm going to show it to you with both models side by side here. Like the T-chart? Comparing, contrasting. Yes, T-chart. Even in math. Okay, so this is the partitioned rectangle model, and this is partial quotients division. Look and see how they are similar. So, for over here, I'm going to say to myself, are there at least 10 4s in 72? Hopefully you could tell yourself, yes, there are, because 10 times 4 is 40, and 40 is less than 72. So if I do that work, I'm going to split that off, leaving myself with some left. I'm going to try and break down those that I would have left. So if I do 72 minus 40, I have 32 left. I'm going to say to myself, can I do another 10 out of that? No, I can't, because 32 is less than 40, so I can't do another one. But I could do 5 4s, right? 5 fours is 20, and that's smaller, so I could take that away. That leaves me with 12 if I do this subtraction problem. And how many 4s could I get out of 12? I can get 3, because 3 times 4 is 12. So if I take 12 away, I'm going to have 0 left over, and then I'm going to add these 3 things up right here as my little partitions, and I get 18. Okay, let's do the same thing over here. So I've got 72, I'm dividing by 4. I say to myself, can I do 4 times 10 and still have that be less than 72? Yes, because 4 times 10 is 40. I'm going to subtract here and say 72 minus 40 is 32. Then I'm saying to myself, what number, let's see, 4 times what number gets me close? Well, I know 4 times 5 is 20, so I'm going to subtract that and put the 5 over here to the side, right? Because 5 times 4 is 20. Notice how I've got the bar here for myself to balance that. So I subtract that, I get 12. And then I'm saying how many 4s can I get out of 12? Well, I can get 3, because 3 times 4 is 12. So I'm going to subtract that. I have 0 left that I need to account for. So I'm going to add these partial quotients together and get 18 as my total. And there's my answer. And there's my answer. Same answer, same basic method, just drawn a little bit differently, right? And that's partial quotients division. So, watch this again if you need to. Slow it down for the pace that you need to take some good notes and to understand it. You're going to, after this, go work on pages 198 and 199 in your math journal. If it's a struggle, it's okay. We'll be definitely talking about it at the lesson. Just do the best that you can do. Use the video as a resource. And we'll talk about it. When you think you've done your best on 198 and 199, come back and check them using a pen so that when I take a look, I know what I really need to talk to you about in the lesson. Okay? When you're done, come on back. And here you go. Here are the answers to pages 198 and 199. And there's the other page. All right. Have a good night. I'll see you tomorrow.